Welcome to another Mr. Paul video. In this video, we're still on 2.1, the integer exponents, but this time we're talking about rule 4, the product of quotients property. Remember, quotients is a way of saying, okay, the result of a division problem, okay? And this property means we're able to rewrite it. And what the product of quotients property says is a to the m divided by a to the n. I'm allowed to rewrite this as a to the m minus n. Now, once again, we've used this in previous videos, but I want to restate this. When we use a, b, m, and n, we're talking about numbers. So in this illustration, we're remembering that this a and this a are the same number. Okay? The bases are the same, meaning this a and this a are the same. If this was a 5, this would have to be a 5. This was a 10, this would have to be a 10. So if you have the bases that are the same, and it's a division problem where you have a number to an exponent, the same number to a different exponent, you can rewrite it as a to the m minus n. Now let's provide some context with this. It makes no sense unless we provide context. So what would this part look like? Well, let's just say we have 7 to the 4th power. We have an a and an m, and it's over 7 to the 2nd power, meaning I have the same base, right? The same number raised to 2 different powers. They could be the same power, but 2 different powers. I'm allowed to rewrite this as a, which was 7, to the m minus n. Now this was m, this was n. So 4 minus 2. Okay, what is 4 minus 2? That is 7 squared. This mess, 7 to the 4th over 7 squared, can be rewritten as 7 squared. Now we could solve this, obviously. 7 squared is just 7 times 7, but that's for another video. But how is this possible? How are we able to do this? Well, let's think about what we're actually doing. Let's take this exact example. If I was to rewrite this top, say 7 to the 4th, it would be saying like 7 times 7 times 7 times 7. This is 7 to the 4th. And I would be dividing that by 7 squared. And 7 squared can be written as 7 times 7. Now, hopefully in math, they've taught you about canceling. When you have numbers on top of the same number, they can become giant ones, right? When you divide 7 by 7, 8 by 8, 10 by 10, they cancel. In math, they say cancel, but what you're actually doing is realizing that 7 over 7 is 1. So you don't, it's irrelevant towards what this value actually is. Another 7 over 7 can be found here. So what's left are just 2 7s on the top. And 7 times 7, which can be rewritten as 7 squared, which is what we have here. This process works even with negative numbers as well. Okay, it works with negative numbers as well. Any number I want for m and n, as long as the bases are the same, I can rewrite it. Let's do a couple more examples. Let me erase some of the work here so I have some room. Remember, this is 7 squared. Suppose I had 3 to the 8th over 3 to the 5th. I have the same base with 2 different exponents. The top one being m, the bottom one meaning n. Okay, I can't get this confused. A's are 3. The top one is m, so it's 8. The bottom one is n, so it's 5. This is equal to a, which is 3, to the m minus n. So m was 8 minus 5. Okay, also known as 3. So this is 3 to the 3rd. Is it important that you write this step? Only if you need it. So for these next two examples, I won't be writing this middle step. Do know that sometimes I just like writing this middle step to help my viewers. Okay? 3 to the 8 minus 5. 8 minus 5 is 3. This 3 to the third, we know how to solve 3 to the third. But we're not going to do that because that's not what this video is about. Let's do another example. What if we had 5 to the 100? Oh my gosh, that's super scary. Over 5 to the 98. According to this rule, 5 and 5, the bases are the same. I can rewrite this as 5, right? The same base to the m minus n. 100 minus 98 is 2. This is something that I like because it's 5 squared. I want to illustrate one more point before I end this video because it's a commonly asked question. What happens, let me erase this here. What happens if I have something like this? 3 to the 5th over 2 to the 4th. What happens if I do this? Can I still use that rule, Mr. Paul? And I'm going to tell you no. No, you may not. That's not how this rule works. Once again, these bases have to be the same number because this whole canceling part doesn't work if the bases aren't the same. For example, this is 3 times 3 times 3 times 3 times 3. And this bottom part is 2 times 2 times 2 times 2. There's nothing for me to cancel. There's nothing for me to turn it into a 1. Unfortunately, if the bases are not the same, I'm stuck with a disgusting math problem. However, if these bases are the same, hypothetically, 6 to the third over 6 squared. Now I'm in business. The bases are the same. In a division problem with exponents involved, I can rewrite them. 6 to the third over 6 squared, according to my property, is the same base, which is 6, to the m, which is the top one, minus the bottom one, which is n. 6 minus 2 is 1. 3 minus 2 is 1. And that's a much easier problem I'd like to solve. That's all for the product of quotients property. Peace.